We are talking about graphing polynomial functions and end behavior, and we want to identify polynomial functions, evaluate by direct substitution, evaluate by synthetic substitution, and graph polynomial functions using tables and end behavior. So first we have to talk about a polynomial. And a polynomial is a monomial or a sum of monomials. Now, here's some key parts. Can't have negative exponents, no negative exponents, no rational exponents, that means fractions, and no variables as exponents. So the polynomial function f of x equals a sub n times x raised to the n power plus a sub n minus 1 raised to the x minus 1 power. That basically just means that if this one has a power of n, then the exponent as we go from left to right is going to keep decreasing by 1. All the way until we get x to the 1, and then we have some constant term. So a couple things to think about. The leading coefficient. The leading coefficient is always the coefficient that is in front of the highest degree. So in this case, our lead coefficient is going to be a sub n. The degree of the polynomial, that is just going to be whatever the highest exponent is. In this case, our degree is just going to be n. And then we have the constant, or the y-intercept. And in that case, that is just a sub o, or the term that does not have a variable. So we can look at some common examples of polynomial functions. So we have a constant function, f of x equals a sub o. In that case, we're just saying like y equals negative 14, and that would just be a line that goes across at y equals negative 14. The next one we have is a linear function, and over here we have the degree. So degree 0, degree 1. So that just means that the exponent is 1. So a sub 1, and then if there's an x there with no exponent, that means we understand that there's a 1 there. So y equals 5x to the first power minus 7. So that's a linear function. Highest degree is 1. Next one we have is a quadratic. In the highest degree, we should know is an x squared. So here we have y equals 2x squared plus x minus 9. So the highest exponent is 2, so this is degree 2. Then we have a cubic. And as we can see, the exponents keep decreasing. So it goes 3, 2, 1, 0. So highest exponent is 3. The degree is 3. So our highest exponent when we have a function x cubed minus x squared plus 3x. And it doesn't have to have all of the parts. So as we can see here, it says plus a sub o. There's no constant term over here. It doesn't have to have all the things, all the different terms filled. The only thing that makes it the degree is whatever the highest one is. Then we have a quartic, which is degree 4. So our highest exponent is 4. So 4, 3, 2, 1, 0. And in this one, we go right from 4 to 1 to 0, right? So we skipped 2, but this is still a quartic function. And then we have quintic, which is exponent of 5. So the degree is 5, so our highest exponent is 5. Now we can take a look at a couple examples. Determine whether the function is a polynomial function. If so, write in standard form and state its degree, its type, and the leading coefficient. So in this case, we got to think back to the earlier example when it said polynomial functions can't have negative, can't have rational exponents, and can't have any variables in the exponent. So for this first example, the only exponent or the only variable we have is x. And so we got to think about what is the exponent for that. And the exponent for that would be 1. So is that a variable? No. So it still could be a polynomial function. Is it negative? No, it's not negative. Is it a fraction? No, it's not. So the first thing, determine, is this a polynomial function? And then, yes, this is a polynomial function. Then it says, if so, write in standard form. And in standard form, we want to have the highest degree first. So we would write this as f of x equals, which one has the higher degree? This has a degree of 0. This has a degree of 1. So then we'd write it as negative 2x plus 13. So that's in standard form where the highest degree is first. And then it says, state the degree. So in this case, the degree is the highest exponent. So the degree of this is 1. What type of function is it? If it has a degree of 1, then it has to be a linear function. And what is the leading coefficient? And in this case, the leading coefficient is negative 2, because that's the coefficient that's in front of the highest degree. The next one that we're looking at is f of x equals 9x to the 4th minus 5x raised to the negative 2 plus 4. So is there anything in here that would make this a non-function? And there is. So in this middle term right here, we have negative 5x to the negative 2 power. And that negative 2 power up there says that this is no longer a polynomial function. So in this case, we'll say that this is not a polynomial. And that is because we have a negative exponent. Then we look at example C, and we have 2 raised to the x power plus 3x to the 3rd minus x squared. And in that case, we have, this is also not going to be, this is not going to be a polynomial because we have the 2 raised to the x power. And because that x is in the exponent, or the variable is in the exponent, that's why it is not. So this is no, because there's a variable as an exponent. And then the last example here, we have example D, and this one is also going to be no. So we have pi times x to the 3rd power plus 1/2 x to the 4th power minus the square root of 3. And another way that we can write the square root of 3 is we can write it as negative 3 to the 1/2 power. And in that case right there, because the exponent is 1/2, this one is going to be, this is no, because there's a because it has a rational exponent.